This video shows several ways of using solar energy for heating and drying in the developing world. These devices primarily heat water, but they can do other things too. The simplest device is shown here with a clear top, a black plastic floor, and inexpensive solid insulation such as straw under the black plastic. Things to be heated or dried go under the clear plastic where they get hot. Here we have 2 buckets of water, one full and one 3/4 full. Each one has a temperature logger to record the temperature, and we can see that on a sunny day, both buckets achieve or nearly achieve 60 degrees Celsius. You can do many other things at the same time, such as drying firewood, purifying smaller containers of drinking water, drying grain, or preheating cooking water to a temperature of up to 70 degrees using the same pot as is used for cooking, and heating clothing to a temperature sufficient to kill insect eggs. Now the downside of this device is that you have to move those heavy buckets of water around, so a possible improvement is to run a copper pipe through the buckets. Cold water flowing through the tube picks up heat from the water in the buckets. Here is the completed system, where the water flows from left to right through the copper tube. This shows the outlet tube temperature on the left and the temperature of the last bucket in the series on the right. The water can never come out as hot as the buckets, but it can come out close. When the water is first turned on, you get a slug of very hot water from the water that was sitting in the copper coil. Then the temperature cools to a steady value, here about 46.5 degrees, as the heat in the buckets is steadily transferred to the flowing water. The advantage of this system is that you can get a large amount of hot water just by opening a valve. A likely application might be in a home that already has piped cold water and wants to have piped hot water, but they don't want to pay for an electric hot water heater or the electricity to run it. And you can still dry wood, dry grain, and do all those other things you can do with the basic device. Now, if you only want to heat water, then the best performance is achieved by replacing the buckets with trays, since each tray gets hotter than the buckets. Each tray here has about 5 centimeters of water, under which there is black plastic and solid insulation, and on top of which is the clear plastic layer to prevent evaporation, then a second plastic layer with an insulating air gap between the two. In the foreground, we have the tray system with a collection area of about 3 square meters, and in the background is the bucket system, also with 3 square meters. The trays always get hotter than the buckets. Here the last tray temperature is on the right, with the outlet temperature on the left. As with the buckets, you get a slug of very hot water at the start, then the temperature settles down to a steady value. On this test, the steady value is about 53.5. That temperature will slowly decrease as the trays decrease in temperature. The temperature of the water coming out of the water mains is 21 Celsius. The water flow for most of the tests I'm showing is 4.5 liters per minute. At this flow rate, we get a steady outlet temperature of 53.5 for a long time. But when my off-camera assistant reduces the water flow by 50%, then the outlet temperature goes up, reducing the flow here. And you can see the outlet temperature rising now. Eventually it will stabilize at about 62 degrees. Thus, you can vary the outlet temperature by varying the flow. For the hottest water possible, then you would use a low flow rate of 1 or 2 liters per minute, and the outlet is nearly as hot as the trays. If you want not so hot water, then increase the flow rate. The water has less time to pick up heat as it flows through the tube, and it comes out less hot than the trays, but still well above the inlet temperature. The application here might be a small hotel or light industry that already has a water heater, either electric or wood-fired, and they want to save energy by preheating the water with the sun. If you do a web search for inexpensive solar water heaters, you'll find a lot of devices to put out a small amount of hot water, but I believe nothing this simple that puts out a lot of hot water. Now here, we're at the end of a 100-liter water draw, which took over 20 minutes. You can see the 5 buckets full of water in this view, which contain a total of 100 liters. The trays have cooled to about 50 degrees, And the outlet temperature is also cooled, but it's still well above the inlet temperature. Finally, I measured the temperature of each of the 5 buckets of water, and we see that each bucket was cooler than the one before it, but all buckets are warm. The total energy for these 5 buckets is 10.1 megajoules. On other days, I did 5 100-liter water draws through the course of the afternoon, and in this case the water is less hot, but there is a lot more of it, and the total energy is greater. I collected almost 28 megajoules on a mostly sunny day and almost 26 megajoules on a partly cloudy day. Now, of course, more clouds always degrades the performance of any of these systems, but even on a completely cloudy day with some light rain, the water still got hot. There are many design variables that you can work with to optimize for either highest possible temperature or greatest possible energy or lowest possible cost. You can optimize to get the highest temperatures early in the afternoon or well into the evening. Contact me for more information.